is the second of 4 tests. When you take this exam, remember, you're going to take 100 questions, and there's going to be like 4 separate tests at 25 questions each. You need to pass each section with 70%. If you get less than 70% in the very first 25 questions, which is called core, and that's what we covered last week, you will not get a certificate if you do not pass core. So you need to pass core as well as type 1 to work in this industry. And those are the 2 main ones you need to focus on for working in the appliance repair field. But I tell anyone, if you're going to study for this test and you're going to pay, study for the full universal, all 4 sections, and we'll go over all of them. But you must pass each section separately, like they're all individual tests. So to begin, let's talk about Type 1 certification, which is considered small appliances. And what people call small appliances is not what we call toasters and mixers and all that. We're talking about residential appliances in customers' homes, especially with refrigerators. The definition of a Type 1 appliance includes products manufactured, fully charged, and hermetically sealed in a factory containing 5 pounds or less refrigerant. So let's talk about that real quick. If you look at this presentation right here, we have 2 systems, refrigeration systems. There's one here with a compressor, a condenser fan, and a condenser down here. And then if we look in the bottom right corner, it looks like it has a compressor and either accumulator or some sort of muffler within the system. But do both of these look like a sealed system?
Well, wouldn't it still be considered a sealed system because you have all the tubes running in and out of the compressor? Because you're going to have to replace something, right?
Well,
eventually.
Here we go. The key word is hermetically sealed. And yes, they're both sealed from the factory, but if you look in the bottom right corner, and I'll expand the image so you can see it. If you look here with this black cap in this corner over here, and I'll circle it with yellow, and the white cap, these are access valves, okay? And these access valves are for you to put your gauges on here. And the white and the black caps are actual valves that you turn by hand to open and close. So this isn't considered a completely hermetic system because it does have access valves on it. That's very similar to central air conditioners. The other part is that this is only the condensing unit. This has the condenser coils in the back with the 2 fans and a compressor in the front. What we are missing is the refrigeration evaporator. We don't have an evaporator system. This might be something that you might see like in a walk-in cooler or some sort of remote refrigeration device. Sometimes in restaurants, they have refrigeration units that have the evaporator inside the unit we're trying to cool, and they put something like this outside to reduce taking up kitchen space and noise and the heat that's produced by the condensers. They pump it outside. So this particular unit wouldn't actually fit in the Type 1, yet it may hold less than 5 pounds of refrigerant. Now this one here, let me bring it to the front. This one here doesn't have an access valve on it. We have the high and the low side. The high side's on the bottom running straight over to the condenser. And the low side's the suction line here. This looks like a Frigidaire unit. And right here to the left, it's a little hard to tell. This is where our process stub is, and there is no valve on the end of it. It's been pinched off and removed. So that's one of the things that they're talking about hermetically sealed. The other thing is the compressor itself. The compressor is inside of this steel ball. So the pump of the compressor and the electric windings of the motor are all within the steel compartment here. If we look, let me just find it real quick here. We can have a, oops, hold on one second. Very similar to like an air compressor for a, an automotive shop where they work on cars and they have to compress air for the tires and everything. Take a look at this. Even though it's not refrigerant,
Bitzer.
See if I can get this video to play.
Bitzer how-to video. Exchanging the shafts. There are two different sealing covers in.
Okay, so this is a very unique compressor, but these compartments at the top are considered the head. And that's where the valves are, and the piston goes up and down at an angle. And by looking at it, both of them, the left and the right, we actually have two pistons. There's one piston going up and down here on the right, and there's one piston going up and down here on the left. And this is the crankshaft that runs through it. Right here, a pulley would go on here with a belt, and this would become a non-hermetically sealed unit. Now we have a shaft here, and there's a rubber seal around it, and refrigerant could escape from that seal. One of the EPA questions later on we're going to discuss is that open type compressors, and this is what they're talking about, could leak if they have not been used for a while from what we call the rotating shaft seal. So that's this seal right here around the shaft that if they don't run enough, the oil in the compressor doesn't keep it lubricated and it may dry out and leak. So if you saw a compressor that had a belt on it or something like this, this would not be considered hermetically sealed. So in that definition, we're talking about like compressors that you would have in residential refrigerators. And let's see, small under-counter ice machines, dehumidifiers, wall and window air conditioners, most of them use hermetically sealed unit. The second part of that definition is that it contains 5 pounds or less refrigerant. So it has to have both of these to meet that small appliance regulation, hermetically sealed and charged from the factory. That means that the factory puts the Freon in. In the bottom unit here, when we connect this to the walk-in cooler or whatever it is, it can either be right outside the walk-in cooler or it could be outside the building. Depending on how far away it is from the unit, they have to run refrigerant lines from the walk-in cooler to this unit. If it's outside, it's very far away. So from the factory, this condensing unit may have a pre-charge in it, but you would have to charge it by superheat or subcooling to make sure that it's properly charged. And what I mean by that is it senses the temperature of the suction line or the liquid line, or we also call it like the capillary tube in a refrigerator, to make sure it's properly charged. Because if you add long lines between these two units, there might not be enough Freon for it to cool properly. So this is what they mean, hermetically sealed, charged from the factory, and less than 5 pounds of refrigerant. I'm going to tell you, 5 pounds of refrigerant don't sound like much when we're talking about it in conversation, but most refrigerators that we work on only contain 4 or 6 or 3 ounces of Freon. So if it's a 4-ounce charge in a refrigerator, you'd have to charge 4 refrigerators to equal 1 pound. Then if you did 5 pounds, you'd have to take 4 and times it by 5. That'd be 20 refrigerators would take to make 5 pounds of refrigerant. So that's a lot of Freon in the small appliance. And what they mean by Type I is your certification. So you guys are studying for this exam and you're going to take the test and you're going to be certified. So what you're doing in this section is going to be certified to work on small appliances. And that's what Type I is all about. So if we look Persons handling refrigerant during the maintenance, service, or repair of small appliances. Now, does that mean if it has a defrost problem or the ice maker is not working in the refrigerator, you need to be certified by EPA? Yes? No?
I had a helicopter flying by. Could you repeat the question? I'm sorry.
Okay, the question is, do you need to have this EPA certificate if the customer's calling you out for a defrosting problem or a problem where like maybe the dispenser or the ice maker is not working?
I think
Yes
so.
to the defrosting problem, no to the ice maker.
What did I heard? How do you say no?
I mean,
What'd you say, Juan?
I said
What?
yes for the
Okay.
defrosting problem, and no if it's just a simple ice maker problem.
Okay. Well, the
I think
answer
if you're touching the refrigerator, you must have the certificate. Period.
actually, if it's an electrical problem or a water problem or a mechanical problem, and let's watch the word mechanical because the AC guys use the word mechanical for refrigeration. But mechanical, like a hinge, a gasket, a door handle, no, you do not need this certification. This certification is solely for working on the sealed system. Defrost is an electric problem. Either defrost heater, defrost thermostat, defrost timer. Defrost is not a refrigerant problem. So Type 1 certification or any EPA certification that we're talking about here, we're talking about the handling of the refrigerant that's inside the system, changing a compressor, changing a dryer filter, repairing a leak, repairing a restriction, doing something that has to do with the refrigerant inside the system. Okay? Now, with the exception of motor vehicle air conditioning, MVAC. Now, this Type 1 does not give you the certificate to work on a car. Or if you've seen like the 18-wheelers, they have the refrigerated back half of the truck that they use to carry refrigerated goods. Those are MVAC type of equipment, and there is a separate test for that. It used to be done by ASE, which was Automotive Service Excellence, and sometimes that test was at the last time I've seen it, I haven't actually administered it for anybody. That is an open exam, but it does not work on refrigerators. Remember, this certificate means you know how to work on and handle equipment that has this type of refrigerant and what you're supposed to do with that refrigerant when you work on it. So that's why there's so many different certifications, because each equipment you have to handle separately. So MVAC-like systems do not meet the criteria for Type 1 certification, no matter the type or quantity of refrigerant. HCFCs, HFCs, such as 404A, cannot be used for new Type 1 appliances. So in other words, that's actually two separate sentences. One is, if you have a Type 1, it doesn't mean you're allowed to work on car ACs. The second thing, HCFCs and HFCs such as 404A cannot be used on new Type 1 appliances. In other words, if you get a new refrigerator, you're not supposed to put R134A in it if it was a 600A unit. Manufacturers now are actually manufacturing product with the new gas, and you're not supposed to revert it back to the older gas. Even though you could change the compressor and flush it out and maybe make it work, technically you're not supposed to do that. So when retrofitting or converting a system, which is basically what I'm talking about, to use a different refrigerant, only EPA approved substitutes can be used. Remember, there's no such thing as a drop-in. We talked about drop-in. Do you remember what drop-in was? Well, drop-in is like if you had...
I honestly don't remember.
Okay, drop-in was where you had refrigerant inside of the system, let's say 134A, and there's another gas that you can buy. It's a blend, it's a mixed gas, and it has the same properties of R134A. And what I mean by properties is we have to look at the temperature pressure chart. If we went to the temperature pressure chart that I have here, if you look at some of these refrigerants, like R22 is 25 degrees below zero at 10 psi, but R502 is 33 degrees below zero at the same pressure. They're very close. And look at 502 and 507, they're only 3 degrees apart. So technically, 502 or 507 may work in the same refrigerant system, might be slightly different because their temperature pressures are so close together. But if you had 502 in a system, you couldn't go and add a little bit of 507 to bring it back up to pressure, even though it's so close. And that's what they mean by drop-in refrigerant. There is no drop-in according to the EPA. So let's take a look now, recovery equipment. Recovery equipment used during the maintenance, service, or repair of small appliances that use CFCs, HCFCs, and HFCs must be certified by approved laboratory. That means if you're going to use a recovery machine, it already has to be EPA approved, and we discussed that earlier. Now, persons who open or perform maintenance, service, or repair of Type I appliances containing these refrigerants can use either self-contained, active, or passive recovery system. So let's take a look here. These are two different items. One is a recovery machine and one is a vacuum pump. Which one of these two pictures is the vacuum pump?
The one on the left.
No.
I'm sorry, the one on the right.
Yeah.
And the one on the left is a recovery machine.
Yes, the one on the left is a recovery machine and the one on the right is a vacuum pump. So even though they both have a pumping system.
One on the right.
Yes. Even though they have a pumping system, the recovery machine is not that well designed where it's going to pull a very deep vacuum for recharging a refrigerator, where a vacuum pump is. Now, there's a question that says, can you use a vacuum pump as a recovery machine? And the answer is yes, but there's a stipulation. First of all, some of these vacuum pumps, you got two different hoses here depending on the size of the input of the gas here that I'm highlighting in yellow. And some of them escape out of the handle. This one doesn't, escapes out of an air vent here. The only way you could use this as a recovery machine is if you took this piece off and you retrofitted it to be able to connect another hose to it so it could pump into your storage device. Now that is only one part of it. Can you use a vacuum pump as a recovery machine? Yes, you can. But you cannot use it on a recovery cylinder that has pressure in it. In other words, if your recovery cylinder had Freon already in it, you couldn't use it to recover the refrigerant out of it. Or out of the appliance into it. It'd have to be in a vacuum, or you'd have to use something called a recovery bag. I don't think I had a picture of it yet. Let me just get it for you here. I actually have a video that I want to show real quick. This is a video that you guys have on your thumb drives from Electrolux. And this is recovering. Just take a minute, take a look at this. It's only 3 minutes long. And then I want to talk about a couple things in recovery.
From a sealed system. This program does not cover those guidelines, so if unfamiliar with them, please take the time to review them. Recovering refrigerant with a pump requires tapping into only the low pressure or evaporator side of the system. A variety of approved pumps are available and differ in their use from model to model, so it's a good idea to review the manufacturer's guidelines for the pump you're using. After tapping into the system and making all the appropriate connections, open the line tap service valve. Start the pump and then open the valve for the waste tank. Most domestic refrigerators hold only 3 to 7 ounces of refrigerant and take about 5 minutes with a good recovery pump to recover the refrigerant from the system. If you are using a recovery pump and tank, you'll need to get a sample of oil out of the old compressor to see if the system has been contaminated. The procedure for recovering with just a bag depends upon whether or not the compressor is functioning properly. If the compressor is functioning properly, you'll use it to draw refrigerant from the low side and push it out of the system on the high side. Tap into the high side at the dryer, where the refrigerant should be mostly in liquid form, making for a better recovery.
Okay, so here they're talking about passive recovery system like a bag, and they'll show you a picture of the bag in a minute. You can either have a recovery tank that has no freon or nothing in it. You pull a vacuum out of your vacuum pump, make sure there's no air. That's a passive recovery tank now that has no pressure on it. Or you use a plastic bag, but the plastic bag is not permanent. That is supposed to be used in a customer's home, and then you take that bag back to your shop and use an active recovery machine to take the freon out of that bag and then store it in a cylinder. So what he's talking about here about connecting to the high side of the system where the dryer filter is if the compressor's operating, you're going to use the compressor to pump the freon. It's going to go through the condenser and come back out to the dryer filter through this line right here at the very top here, this skinny line right here, and then you could recover it as a liquid. There's going to be very rare that you're going to recover from the high side using the compressor, because 9 out of 10 times you're doing a sealed system job either because you have a restriction, a leak, a bad compressor. I mean, those are like the major problems. If your restriction is in your capillary tube here after the dryer filter, I'm sorry, I clicked on it by mistake. If your restriction's here after the dryer filter, then you can use the compressor to pump the freon through the high side, and it'll speed up your recovery process because it condenses that freon into a liquid, and that can go into a bag or go into an unpressurized tank. If the compressor's no good, this is going to probably also be needed to be put a high side and a low side, and the low side would go on here on the process stub, because now if the compressor's not working, you're going to need both hoses connected, the high pressure, which is here on the dryer filter, and the low pressure, which is here on the compressor, because if it's restricted or the compressor's bad, by connecting to both sides of the system, you'll speed up your recovery. Okay, so let's take a look. They're going to show you now the passive recovery bag.
Connect a hose from the service valve to the bag and open the valve. Start the refrigerator and let the compressor run. It will draw all of the refrigerant from the low side and pump it out the high side. It's very important to understand that recovery bags are designed to hold a specific amount of refrigerant. The bags are large in volume so that when gravity feeding refrigerant from a system with a dead compressor, the bags will accept all of the refrigerant from the system. While the bags may appear to be able to hold more than their specified capacity, you must never exceed that capacity. Doing so by as little as 2 ounces will usually rupture the bag.
Okay, in other words, the bag is so big. The reason is that the bigger the bag, the easier the freon's going to come out of the refrigerator. Now, if the compressor's not working and you're using something like this, where you need to use like a hair dryer or a heat lamp, and you would heat up the condenser and you would heat up the evaporator to help chase the refrigerant out of the product. That'll help you assure that you get at least 80% of the refrigerant which is required by the EPA.
Let the compressor run for at least 10 minutes. As refrigerant travels into the bag, there's a certain amount of compressor oil that travels with it. This is a great opportunity to look at that oil and get an idea as to the condition of the system. As oil starts to overheat, it will begin breaking down and turn to a real dark brown color. Look around the service valve. If you see dark oil instead of clear, then you probably have a contaminated system. This system of recovery works quite well as long as you have a good functioning compressor to work with. If you're using the recovery bag and do not have a functioning compressor, you will have to tap into both sides and let gravity drain the system. Once you've made the connections, open both service valves and then the manifold. It'll take at least 15 minutes to gravity feed refrigerant out of a system. You should see a slight raising of the bag as the refrigerant goes into it. Look around the service valve and in the recovery bag. If you see dark oil instead of clear, then you probably have a contaminated system. When using a recovery bag, you'll still have to pump the contents into a waste tank when you return to the shop. Hook the bag up to the pump, just as you would if you were recovering with a pump to a tank. Turn on the pump, then open the valve.
So if it's contaminated, are you replacing the entire compressor, that entire system?
Most likely, if the oil is contaminated, you want to replace the compressor, but not only that, but you want to take nitrogen and flush the system out and try to make sure that there's no trapped oil
Okay.
in the condenser or in any of the lines. Okay, but that was a good question. So let's go on here. So persons who open, perform maintenance, or repair Type I appliances can use either active or passive recovery equipment. A domestic refrigerator is an example of an appliance which it would be permissible to use passive recovery device. That means the bag or a tank that's in the vacuum using the compressor of the appliance. System dependent or passive recovery equipment used for appliance containing HCFCs and HFCs is limited to a maximum charge of 15 pounds. So in other words, if you're using a recovery tank, a 30-pound tank, technically, if you're using an active recovery machine, that means this type of recovery machine right here, this is an active recovery, you could put 80% of the charge that that tank will hold. If the tank is a 30-pound tank, it'll hold 80% of that, which would be 24 pounds. But if you're using a passive recovery machine, which is what they said here, you can only go up to 15 pounds into that system. Again, most of you guys only work with Type I appliances, even central air. Most of them don't use more than a couple of pounds of Freon. So when you're trying to recover 15 pounds, passive recovery, don't go into a system that is already charged. So you're not going to put 5 pounds in a passive system and then go to someone else's unit and then recover more. Once you've filled up that passive system, you're done filling it up. It's got to be empty when you use it on the next system. So to get something with 15 pounds, again, that's something that's quite large. Now, maintenance practices for recovery equipment should include checking for refrigerant leaks and oil levels on a regular basis. A refrigerant scale or tank with internal float device are acceptable methods for monitoring the fill level of the recovery tank does not exceed 80%. So you either put the tank on a scale or you have a tank that has a float device. Once the liquid refrigerant in that tank reaches, let's say a 30-pound cylinder reaches 24 pounds, that's it. It won't allow any more refrigerant inside. Now, self-contained recovery devices for use with small appliances containing these gases, I'm not going to read all the letters, must be able to recover 90% when the compressor is operating and a 4-inch vacuum, or 80% when the compressor is not operating. So they're talking about is that if the compressor works, use the compressor to help get that extra ounce or two of refrigerant out. Okay? So if the compressor works on the appliance, you must get 90% of the charge. Now, if it's a 3-ounce charge, 90% is 2.7 ounces. 80% is 2.4 ounces. We're only talking about 0.3 of an ounce. We're talking about very, very small, minute amounts. When I say 80 or 90%, we're not talking about 3 pounds or 5 pounds. We're only talking about just ounces or tenths of an ounce. Refrigerant recovery devices used to recover these gases can either be manually closed or automatically closed when disconnected to prevent the loss of refrigerant from hoses. When attaching a gauge to a check system, pressures, hoses, or manual self-sealing valves on the ends should be used to minimize the release of refrigerant. So we're talking about what we call low-loss fittings. Now, if you look here, these are what we call low-loss fittings. This hand valve here, this end would be attached to a hose, and this would go to the appliance. And when you disconnect it from the appliance, you shut this valve off here, and then as soon as you remove it, only a little bit of freon will come out. On the older hoses, there was no hand valve here, and it would just leak out all the refrigerant that's in the hose and maybe some out of the system. So you could add these to the end of your hoses, or you could buy hoses already with hand valves on them. And some of them come with different lengths, that like a hose instead of just a solid fitting. Now over here, this is not a low loss fitting. If you look though, this one, the opening is wide open. And if you look, there's a piece of metal in there. Does anybody know why this is on this side? It has nothing to do with this no flow word here. But why does this piece have a metal piece in the middle of it and this one doesn't?
A valve?
Well, be a little more specific.
Does it connect to the valve? Is that the end that connects to like a valve, like a shut off of some kind? I'm not sure, honestly.
Well, actually, every time you say you're not sure, you say, honestly, I'm not sure. I'm not sure. Schrader core valves. This is a Schrader core. Okay, this is the same thing in your bicycle tires, the same thing in your car tires, and everything else. And they have access valves that have cores in them. So let me just put stem valve. So a stem valve is a, let me put a refrigerant because we have to, refrigerant stem valve. These are stem valves here. Let me see if I can get another image real quick. So this is a refrigerant stem valve. This is a refrigerant stem valve. But if you look, there's nothing there inside that pipe. When you get stem valves, they have these cores inside of them. I was hoping I could find one where you could see the inside of it. But I don't know if you ever put air, try to take air out of a bike tire or a car tire. They have these little valves inside of them that you have to press down on to let air out or let air in. So by looking at those two hoses I showed you, this one here, this little metal piece is what presses down on that core inside the access valve. I've had guys in the class by mistake put this one here on the left to the refrigerator, and they put this one to the vacuum pump, and they pulled a vacuum, and then within 2 minutes they reached the required vacuum. Like, Richard, I'm done. I got 500 microns. Yeah, but they didn't press down on the core here, and so they didn't actually evacuate the refrigerator. They only evacuated the hose and the gauges. So you got to make sure that the piece with this core depressor, they call it, is the part that goes on the access valve on the appliance. When you remove it, the appliance access valve is a low loss fitting, but this hose does not have a way to prevent Freon from leaking out of the hose. So if there's an ounce inside of this hose of Freon and you take it off of the refrigeration system, you're going to lose that Freon out of the system. So let's move on. Remember, guys, if you have a question, stop and ask me. Okay, refrigerant charging cylinder with a regulated refrigerant. The refrigerant that is vented off the top must be recovered. So I have a picture here of a dial charge. We have something very similar to the class. There's a little glass tube that runs up the middle of it here. That's what number 4 refrigerant cylinder is. And there's usually a valve at the bottom and a valve at the top. In this case, they're both at the top. One goes to the top of this pipe here, and one goes to the bottom of the pipe for like example like this. Well, when you're adding Freon, you turn your tank upside down. So your refrigerant tank is upside down, standing on the handles here. And you connect from here into the system, and the liquid is supposed to rise up here as it leaves your tank. And your tank now, the liquid level, because you turn the tank upside down, everything below here is liquid. So it flows into the charging cylinder. But when the pressure in this cylinder is the same as the pressure of the tank, it doesn't fill up with any more Freon. And we need to sometimes get about a pound or 2 inside this system. So what technicians used to do is they open up the valve at the top, and any trapped vapor refrigerant or air would be vented outside. Now the EPA says you're no longer allowed to vent that air. You must recover that refrigerant leaving the top of the system. I'm sorry, the top of the cylinder, to make sure that we don't vent that. So that's what they're talking about, collecting the refrigerant that's vented off the top.
Couldn't you use a vacuum?
Well, you could use a vacuum on the recovery cylinder before you charge it. But if you don't get enough Freon in your recovery cylinder and you need to get a little bit more in, the only way to do it is to let a little vapor off the top as you're lowering the pressure in that cylinder so more liquid could run from the tank into it. So it isn't a pulling a vacuum. Yes, you could pull a vacuum before, and it's recommended you do so there's no air inside as a freon's coming in. But you know that once its pressure is the same as the pressure of the tank, no more refrigerant wants to run over there. So you have to figure out a way to get some more liquid in there, and sometimes just by releasing the top of that and letting a little vapor off the top of it, it's allowed to charge it up with more liquid refrigerant so we can use it to charge the appliance. So recovery requirements. R600A is approved refrigerant for new household refrigerators, freezers, and combination refrigeration freezers. So basically, our small appliances now, they're going to use R600A instead of 134A. Hydrocarbon refrigerants are not approved for retrofit into existing household refrigerators. In other words, you can't take a 34A system, put a different compressor on there, and make it work. Probably could, but it's not approved by the EPA. So new SNAP regulations have approved these refrigerants, which 600A is the most popular one right now, for newly manufactured household refrigerators. So SNAP is a keyword that's used in core. When you read the book, you'll read it. And that's saying that these gases now are approved by the EPA to use in refrigerators. Now, recovery techniques. When servicing a small appliance to be leaking, it's not mandatory to repair the leak, but it's recommended to do so whenever possible. So if you go to someone's house and they have a freon leak and you say, well, I can charge it back up and get it cooling. If it leaks out in 6 months to a year, by law, they don't require you to repair it. You can charge it back up as many times you want. Problem is the cost of constantly charging a refrigerator and the hassle of constantly adding freon and lose partial cooling before you do that. It's better you just repair it if you can, or figure out a way to replace it. Get a new refrigerator. So before beginning refrigerant recovery procedure, it's always necessary to know the type of refrigerant that's in the system to prevent mixing in a recovery cylinder. This is an EPA test question. Both of those. One, you don't have to repair a leak in a Type I appliance, but do so whenever you can. And two, before working on a refrigerant, you need to know what type of refrigerant is inside the system. How do we identify what refrigerant's in the system?
You can look in the manual.
Well, what if the customer don't have the manual?
You can look up the model number.
Uh,
The manufacturer's website.
your phone is horrible. Your microphone.
I'm so sorry. I said you can look up the model number on the manufacturer's website.
I don't.
It might tell you.
I'm unable to understand you, Juan. But
Type it.
if you look at the manual, I thought I could find some images of it, like with the model and serial number. Let me see something. I thought I heard somebody come in. Okay. So if you look at the model and serial number on a refrigerator, if you look like here, true, master built, and these different manufacturers' model numbers. Let's just take a look. If you look at this one here, let's open it up and to make it a little bit larger. The model and serial number here tells you the type of refrigerant as well as the charge, and this one here is in grams of 134A. If we look at this one here, let's take a look at this model and serial number. This one here also says 134A. They don't have the charge on this one, but normally the charge will be here, how many ounces are inside of that refrigerator. If we look at some of these other manufacturers, True being a commercial refrigeration system, they do make some home residential. It tells you here, they blocked it, refrigerant Oh, here it is right here. Refrigerant 404A. This thing takes 27 ounces of Freon. Remember, 16 ounces is a pound. It's almost taking 2 pounds of Freon for a charge. So this is a commercial unit. Okay, so we look at the model and serial number plate, and on those model and serial number plates are going to specify the type of refrigerant and how much is used to charge that refrigerant system. So R744, or well, actually, it's an acceptable to mix in refrigerants, but it's not against the law. If by a pinch you're doing a job and your tank is full and you can't use the 134A tank to recover any more 134A, and you have to use another tank, you can mix it. But remember, the company that reclaims it doesn't have to accept it. They might consider it damaged and have to destroy it at your cost. Or they could try to clean it, but it would be at your expense. R744 carbon dioxide is a very high pressure refrigerant and generally does not need to be recovered. You're really not going to see those on our small residential systems in customers' homes. Now, when 4-ton A or any other refrigerant is recovered from an appliance, it should be recovered into a recovery vessel that's clearly marked as to its content, like in the picture here to the right. 410A is used in the wall and window air conditioners. They're hermetically sealed. They don't have access valves on them. And they usually contain less than 5 pounds of Freon, so they fit into the Type I appliance and can be worked on even though they're not 134A or 600A, as a technician has a Type I certification. Now, comparison to temperature pressure chart are the only valid check for contaminated refrigerant. So if we go back to that temperature pressure chart I had here, by looking at this chart, they're going to measure the temperature of the refrigerant, and based on the temperature, if you're using R22, for example, it's got to meet the temperature and the pressure got to match up to the chart. If they do not match temperature and pressure, then we might have a problem with the refrigerant being burned out, mixed, have moisture in it, or some other non-condensables. So this is the temperature pressure chart, and they would test that to see if it's a good refrigerant. So when checking for non-condensables inside a refrigerant cylinder containing one refrigerant, technician must allow the temperature of cylinder to stabilize to room temperature before taking a pressure reading for comparison. That is an EPA question. So when checking to see if there's non-condensables like moisture in the system, they need to make sure that the tank, let's say it was in their truck and they go into a service center or their shop, they cannot check the pressure and the temperature right away. They have to wait till that tank cools down and reaches the temperature of the room. Once that happens, then you can measure it against a temperature pressure chart. If a technician suspects that the refrigerant to be contaminated, a pressure measurement should be taken and compared to pressure temperature chart. If the temperature relationship does not match, the refrigerant should be turned into a reclamation facility. Some reclamation facilities may refuse to accept it or charge extra for processing or destroying it, which I said earlier. So let's take a look a little bit here at this presentation. To work on a Type I type of appliance, you must have a Type I certificate. What about if you're universally certified? You know, you can work on...
Then
Go ahead.
that should allow you.
To work on everything. If you're universal, no.
Yeah, if you're universal, that means you're Type 1, Type 2, and Type 3 certified. You have them all. If you're missing one of them, it'll just say Type 1, Type 1, Type 2, Type 1, Type 3, Type 2, Type 3, Type 3. It'll tell you what certification you have as far as what you're certified to work on. If it says universal, then you can pretty much work on anything. You had something to add?
Oh no, nothing to add.
Okay, so this is Type 1 certification. There's just a little bit more. I'm going to save that for the next lecture. we talk about safety and stuff. And well, actually, let's just finish it up. We're almost done here. So a service aperture or process stub typically used on small appliances is a straight piece of tubing that's entered using a piercing access valve to add or remove refrigerant. So let's go back to that picture again of that condenser. The other way, I guess. And we'll take a look at this picture. If you look at this compressor, there's a process stub right here, or a hose right here, that you can use to connect to the refrigerant system. And that's what they're talking about, the process stub. It's the same as the low side, and they're interchangeable. But from the factory, they're supposed to leave a little pipe on there so a technician can put a temporary valve on there to recover the refrigerant from the system. So that's what they're talking about there. So because solderless type piercing valves tend to leak over a period of time, they should not remain on a refrigeration system after completing repair. Manufacturers do not want you to leave any valves on after the repair, and they may consider that to be a violation of their warranty. So changing a compressor, if another company comes out behind you and says, hey man, there's valves all over this thing, someone did a compressor job, the manufacturer might come back to you and say, hey, you changed the compressor last week, we're checking our warranty records that you did a compressor, but a technician came out and said there's all these valves on there. You're not supposed to leave them on there. They might take away your factory authorization, so just be aware of that. So a passive system-dependent recovery process for small appliances can capture refrigerant into a non-pressurized container, the bag, or a tank in a vacuum. When using passive recovery devices, small appliances without operating compressors, it's essential to take measures to help release trapped refrigerant from the compressor oil during refrigerant recovery. It's helpful to heat and strike with a heat gun and strike the compressor with like a rubber mallet. So refrigerators don't catch too much, but if the compressor is bad, some oil can mix with the refrigerant and trap the refrigerant. So what they're saying is if you're recovering and you're using a passive recovery instead of a recovery machine and trying to like force the refrigerant out, they want you to heat the compressor and just wrap it lightly with a rubber mallet or something to help chase that refrigerant out of the oil and get that extra little bit. The higher you go up, when you have a 300-pound chiller system, it could contain up to 100 pounds of refrigerant in the oil. That's a lot. So as the product gets bigger, it's more important to recover that amount by heating and striking the compressor to chase the refrigerant out. When using the system-dependent passive recovery process and the compressor does not run, both the high and the low side of the system must be accessed for refrigerant recovery. And we said that. The compressor don't work, you need to put a valve on both sides of the system. Both low and high side access valves should be installed when recovering refrigerant from a household refrigerator or in any other appliance to improve the speed of recovery. Listen, when you're a technician, you're going to have a bunch of other service calls besides that compressor for the day. So you don't want to sit there and just access one side of the system. It's going to take you forever. So make sure.
Hello?
I'm sorry? Say it. Juan?
It just froze. I'm so sorry. I said hello because I just wanted to know you were still there.
Oh, yeah. You couldn't hear me? You can't hear me?
It froze for just a brief moment. I'm sorry.
Okay.
Yep, it's lagging a little bit.
All right. Well, you can watch the recording again to catch up anything you missed, okay? So to ensure that our refrigerants move from a faucet refrigerator, the defrost heater can be energized to increase the refrigerant's temperature and vaporize any liquid. That's all well and done, but if you're capturing refrigerant, most likely the unit wasn't cooling, and most likely the defrost thermostat is open, so the heater won't even come on. And when you're capturing from a cold unit, 9 out of 10 times while you're recovering the Freon, if it's cold enough to close the defrost thermostat. So they're saying if you get the heater to work, bypass the thermostat. You got to be careful though. If that heater stays on for too long, it's going to start melting the plastic and could even damage the evaporator. An appliance with an operating compressor and completely restricted capillary tube or metering device requires only one access valve on the high side of the system. And I said that. If your capillary tube is restricted, you can put an access valve on a dryer filter because that's before the capillary tube, and just turn the compressor on. It'll help chase the refrigerant out. Okay? If the pressure of the appliance is 0 after installing an access valve, you can't recover because basically there's probably no Freon in it. It might be leaked out. So when using a self-contained active recovery device and there is a large volume of non-condensable gas and refrigerant being recovered, excessive pressure can occur on the high side of the recovery machine and the recovery cylinder. So in other words, if you got a lot of moisture or air trapped into your system and you're recovering it, it could trap inside your recovery machine and make it harder for it to compress that refrigerant and condense it into a tank. So the approximate pressure of 134A cylinder does not contain any non-condensable impurities at 80 degrees is equal to a pressure of 87 psi. And we said that earlier is that 134A is pretty close temperature to pressure. So if it's way far off, then there's something wrong with that gas. As long as there's liquid refrigerant present and no impurities in the cylinder, the pressure and temperature should match what is shown on the PT chart, which is pressure temperature chart. That's what PT is. Now, during system recovery and or repair, a pungent odor is detected from the refrigerant. This normally indicates that the compressor had a burnout. Refrigerant is colorless and odorless. If you open it up, you could get a small little odor from the oil. Sometimes people open up a system and say, oh, I smell the refrigerant. No, it might be the oil in the compressor you smell. But if it smells like almost like a rotten egg kind of smell, the windings in the compressor might have shorted out and contaminated the oil and the refrigerant. And you had what they called a burnout in the system. The technician should watch for signs of oil contamination when recovering refrigerant from a system that has experienced a burnout, as this will have to be flushed and contaminants are present. Nitrogen is used to pressurize or blow debris on the system. Nitrogen may be vented to the air. So in other words, you could disconnect some of these lines and put some temporary valves on the system and flush it out with nitrogen to try to get out any trapped oil or moisture in that system. Now, safety. Household appliances charged with hydrocarbon. This is something new that's been added to the Type I because we did not have HC a couple of years ago. So household appliances charged with HC refrigerants like 600A require permanent safety markings on any or near any evaporators exposed refrigerant tubing, the machine compartment, and the exterior of the refrigerator. Usually you'll see red like covering over the pipes indicating, hey, this has got hydrocarbon, which also is like isobutane in it, and it is flammable. So they do color it a different color. When you're servicing it, you're supposed to cover it back up with these sleeves that indicate that it is a 600A system for the next technician. When recovering refrigerant, safe work practices include wearing safety wear, butylene gloves, when connecting and disconnecting hoses. When using nitrogen to service, leak test, or purge a refrigeration system, the nitrogen tank should be equipped with a regulator. Because refrigerants are heavier than air and displace oxygen, a very large leak can cause suffocation. Now, if a refrigerator leaks Freon, it's only 3 or 4 ounces. But if your 30-pound cylinder leaks out while you're in a small confined space, it could rob you of oxygen and you could pass out and possibly even die. So self-contained breathing apparatus, that's SCBA, so self-contained breathing apparatus. That's almost like what we're wearing now, masks. But they do have filters that filter out refrigerant, and they have like a little air tank on the back. So it's almost like a scuba tank, but it's not waterproof. So scuba is SCUBA, and SCBA is self-contained breathing apparatus, where scuba is self-contained underwater breathing apparatus. So all they did is take the U out when they said SCBA. Vacate and naturally ventilate the area. So if there's a known leak in a small confined area, you're basically supposed to have this apparatus there to protect you. It's really not that important on a small refrigerator, but when you're working on larger equipment in a small confined space, if it leaks, they want you to open up the doors and windows and get out of there. Let it air out before you go back in and work on it. At high temperature, CFCs and HCFC refrigerants can decompose into phosgene gas.